Hello everyone. Today we're going to be starting our new unit going over exponential functions. So up until now we've only covered linear and quadratic. This is the third type of function that we cover here in Algebra 1. So by definition, an exponential function is a function in which the independent variable x appears as an exponent. So here's our parent function, what it'll look like. Y equals a times b to the x power. See how x is that exponent? It's always going to be in this format. A and b will both be numbers. Now today what we're going to be talking about are its key features or its attributes. It has some of the same ones as the other functions have, but what's special about exponential is it has this new one that we've never done before. It has an asymptote. So an asymptote is the line that the function approaches but does not cross. So we haven't looked at a picture yet, but when we do look at a picture, you'll notice that it gets closer and closer to a certain line, but it never actually touches it. So for exponential functions, they have horizontal asymptotes at y equals 0. Okay, here's a familiar one, y-intercept. This is the initial value of the function when x is equal to 0. Or when you're looking at a graph, it's where the function crosses the y-axis. Okay, so what's cool about exponentials is that the y-intercept is always going to be located at 0, comma a. And that a I'm getting from the equation up here. So whatever number happens to be there, that's going to be your y-intercept. Okay, so one more thing that we describe about exponential functions is there's actually two different types. There's exponential growth and there's exponential decay. So starting with exponential growth, when b is greater than 1, the graph increases from left to right. So that's the important part, b. So if you remember the equation, b is what's inside the parentheses. We call that the growth or decay factor. So whatever number is inside the parentheses, the one that has the exponent determines whether it's growth or decay. And when it is bigger than 1, so 2, 3, 4, 5, you name it, the graph is going to increase from left to right, as you can see in this picture here. And it has the other attributes as well. So where it crosses the y-axis, that's called our y-intercept. And it has a horizontal asymptote right on top of the x-axis, but that's the line y equals 0. So what's happening is our function, it's getting smaller, 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 and it actually looks like it's right on top, but it's never touches actually. It's never going to go across that line. But we said there's two types. So the other type is exponential decay. So when b is less than 1, so 2/3, 1/4, 1/2, 0.75, things that are smaller than 1, the graph is going to decrease from left to right. So see how it's getting smaller? And it still has the y-intercept. And then it still has our horizontal asymptote at y equals 0. So those are the basic characteristics of an exponential function. You need to for sure know where to find your y-intercept. So whether it's on a graph, you're just going to look to see where it crosses, or in the equation, it'll be the first number. You need to know whether it is exponential growth or exponential decay. So when you're looking at a graph, it's pretty easy. Growth means that it's going up. Decay means that it's going down. But when you're looking at an equation, you need to look at the number here. And if it's greater than 1, it's growing. If it's less than 1, it's decaying. Okay, and then last is the horizontal asymptote. But for the purposes that we're going to be doing here in Algebra 1, it is going to stay at y equals 0 every single time. So we have 4 examples to look at. I want to label all of these attributes by looking at a picture of a graph and by looking at a equation. Okay, so let's start with this first example. So first I want to know, does this represent growth or does it represent decay? So when I look at this graph, and remember we read it left to right the same way we would read a book, this graph is going down. So this is exponential decay. Okay, then we want our y-intercept. We look at our y-axis and then we just look to see where it touches it. Touches right here. So our y-intercept is at the point 0, 3. And then last is the asymptote. So see how it's getting smaller, 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 but it's never going to cross that 0. It's never going to turn to these negative numbers. So the y-asymptote is at y equals 0. Okay, let's take a look at another one. So here's my new graph. First, I want to decide, is it growth or is it decay? So when we read left to right, this graph is going up. So we call this growth. Okay, y-intercept. Look at the y-axis and see where it crosses. So right there at the 2. So 0, 2. And the asymptote is still at y equals 0. And you can see that it almost looks like it's on top of it, but it's getting super close to that bottom line, but it's never actually going to cross. So like I said, graphs are pretty easy to physically see what's happening, but I want to find all of these things when I'm just looking at an equation. So let's look at example number 3. Y equals 4, parentheses 1.5 to the x power. So first, I want to decide, is it growth or is it decay? So what we look at, so according to my notes from up here, we're going to look at B, so what's inside of the parentheses. That determines whether it's growth or decay. So for us, inside those parentheses, I have 1.5. Okay, now 1.5 is greater than 1. So because it is greater than 1, this is going to represent exponential growth. Okay, now I want to find my y-intercept. This is super easy. It's the first number, 4. So 0, 4 is our y-intercept. Okay, and then last, where is its horizontal asymptote? Like I said before, for what we do here in Algebra 1, the asymptote is always going to be at y equals 0. Okay, so let's take a look at one last example. I have the function y equals 5 and in parentheses 1/3 to the x power. So I'm going to actually do this one left to right instead. So starting with that 5, that's the y-intercept. So y-intercept at 0, 5. Okay. Then whatever is inside of the parentheses, that is our growth or decay factor. And the way we decide which one it is whether or not it's greater than or less than 1. So 1/3. 1/3 is less than 1. So that makes this one exponential decay. Okay, and then last but not least, it's going to have an asymptote at y equals 0. Okay, guys, and those are the important characteristics of this function. So we are going to practice this today and then again on Wednesday. But after we learn these characteristics, we are going to learn how to write and graph and solve and all the good stuff. So for now, you have an exit ticket to complete that's in the Schoology folder for today. And let me know if you have any other questions. Bye.